Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is indexing to access a vector's item. Before proceeding, make sure that you have already watched these other videos first. Both the array bracket operator and the at function allow random access to any particular vector item. This indexing is always zero-based, so both of these forms where the programmer has typed the numeral 3 will actually access the fourth item. Both of these forms, the array operator and the at function, provide a reference to the item. So indexing can use either of these forms for getting the item's value, or on the left-hand side of an assignment for setting the item to a value. However, if the array was a constant, then a constant reference would have been obtained. It is the programmer's responsibility to ensure that a valid index integer gets passed to the at function, or programmed within array bracket symbols. If the size of the vector is 5, then that index integer must be greater than or equal to 0 and less than 5. If an invalid index is passed to the array operator, then a runtime error occurs. If an invalid index is passed to the at function, then it throws an exception. There are special names for accessing the first and last items of a vector. To access the first item, call this front function. To access the last item, call this back function. Again, these return a reference that could be assigned to, so these front and back could be on the left-hand side of an assignment statement. Because a vector guarantees that its items will be stored contiguously in memory, when you have this vector of characters, you are able to treat the address of its first item as if it were just an ordinary C language string of characters. Calling this data function is just the same thing as programming the address of first item expression yourself. In either case, all access to memory via this PC string variable must stay within the vector object's allocation area. Any vector operation which removes, inserts, or assigns data may potentially cause a reallocation of that vector's internal representation. Because that reallocation might happen, all iterators should be considered invalid after that operation is done. And so those iterators would need to get acquired once again. Furthermore, any item references or item pointers should also get reacquired.